At the Allen Coral Atlas, groundbreaking science lays the foundation for the habitat maps, bleaching monitoring system, and other features that make the Atlas what it is, a tool to protect the world's coral reefs. My name is McKenna Flynn, Atlas Comm Specialist, and today I am so excited to kick off the Science Talk series today with Dr. Emma Kennedy, coral reef ecologist at the Australian Institute of Marine Science. Previously, Dr. Kennedy was a postdoc at the University of Queensland in the School of Earth and Environmental Science, where she developed and published Reef Cover, a coral reef classification for global habitat mapping from remote sensing. Now, I am stoked to hear about Reef Cover and more about your research, but first, can you share your story and really what led you on this path to coral reef science?
So I love animals. Like I've always been animal crazy, but I always loved not the like traditionally kind of cute and fluffy ones, but all the totally crazy ones. So the more legs they had, the more eyes, the weirder they were, the more interesting I thought they were, and the more fascinated by them I was. So I ended up studying zoology at university, and coral reefs are just the greatest place on earth if you're into weird animals, because they have more strange creatures packed per meter squared than anywhere else on earth. I think rainforests rival them in terms of biodiversity, but that's mostly dominated by insects, whereas you have like huge numbers of different phyla represented on reefs. So you have things like crustaceans and shrimps and like anemones, corals, fish, like worms, sponges. It's just really, really cool place to work if you love animals. And I guess once I got into coral reefs, I was kind of really hooked. But with reefs degrading all over the planet, like a lot of scientists aren't able to study, I guess, what we traditionally like to study, like looking at animal behavior and biology. And so I moved into ecology, which is the field of how all the different organisms on the reef kind of interacting with each other and also with the environment. And so really starting to understand like how climate change and environmental changes are impacting all the communities that live on reefs.
Awesome. Well, that's awesome to kind of hear about your story. And this led you to Reef Cover, this kind of fascination with coral reefs. And can you kind of explain a little bit more about your research, this research that set out to define a classification system? I'd love to hear more and your study's results.
Yeah, so reefs are like these huge underwater structures and shapes, and they're so beautiful. And if you jump on the coral atlas, you can see them in all their beauty. But some form, kind of donuts, and some you find in these like really like long, thin, ribbony structures, like in the north of the Great Barrier Reef, and some separated from land, and some are connected to the land. And you often get really big regional differences in the shapes and sizes of these reefs. And then within the like those big reef structures, there's like lots of repeating patterns that you see again and again and again. I guess it's a little bit like dogs. Like dogs come in all shapes and sizes, but they all have a head and a tail. And it's the same with reef. It's like most of them will tend to have like what we call a fore reef, or like a sloping front. They'll have like a flat kind of top, which we call the reef flat, and then they'll have a tapering back often. And some have other special features like lagoons or patch reefs. But people have been classifying reefs and their structures for a really, really long time. I think even in the 1800s, Darwin was starting to name some of those different reef shapes, the atolls for the big round ones, or barriers or ribbons. And then some of the geomorphic features that you find inside, so like reef tops and flats as well. And a lot of those are really like obvious, and they're important to know because they change the like type of communities of animals and seaweeds that you get growing there, and they have quite different conditions. But as time's gone on and technology's improved, and we're able to start looking at reefs from all different perspectives, from space and from underwater, we're discovering more and more parts to these structures, and scientists have been describing more and more different features. And so we're getting more and more different names to try and describe all of that different variability. And it was really kind of starting to get really confusing. And so classifications are designed to help us make sense of the world. And so looking at all of that different literature out there and all of the different descriptions for different features of reefs, and trying to put everything together, review it, and come up with something that was like really clear going forward, particularly as reefs around the planet are facing these really big global challenges. And more we want to have big global conversations around big global maps like the Allen Coral Atlas. And what we kind of need is like a common language or a big kind of dictionary, so that everybody's on the same page when we understand what we're talking about. And so that's really what we were trying to do with this classification.
Got it. So you've really, like you said, yeah, no, it does. And so you've created in what you called a dictionary for coral reef habitat mapping, and specifically looking at the structure of the reefs. So what has this impact kind of been like? What have you seen? Have you seen people using this type of information?
Well, yes, like there's two ways that this kind of information can be useful. So it can be useful for people creating and building maps themselves. So we did actually a big review of a lot of the coral reef and seagrass maps that were out there. And what we were finding was with the map classes, there was often like a name associated with each class, like back reef or lagoon, but often not a more detailed description of how the mappers came to like understand these and what exactly they mean. So for people reading the maps, it's not always obvious exactly what the class is. Mappers that are creating maps, the Reef Cover creates kind of guidance with some of like the definitions of the different map classes, like the history of where those names came from and what they mean in terms of the kind of biophysical structure of the reef and how we see them from mapping from space. But also for users of the maps, it creates like a more detailed kind of legend. So if somebody's examining a map of a reef in Indonesia and they see a map class called reef front, they'll know exactly what that means, and then they'll be able to relate that to like a map in Bermuda of reef front and know that there's like some rules that will be consistent. And so it just kind of adds meaning for the map users. So hopefully it empowers the users of the maps to really interpret the maps properly and make decisions about whatever they're wanting to use the map. And also for creators of maps to get clarity around like linking what the biophysical environment means and what we can see from space to actually kind of meaningful different reef habitats.
Got it. And so when we look at the atlas, for example, we're seeing 12 of these classes that you talked about in your research available as part of the habitat maps, and it kind of classifies them. And we even have a link that explains what these different classifications are. Can you kind of touch on what this means for people using the atlas, and how when they go to these geomorphic maps, what they're understanding by looking at it?
Yeah, so previously somebody like working in the Caribbean might have seen something like back reef or something that was called back reef. Their understanding of that might have been really different to somebody like working in the Pacific, or a geologist's understanding of what back reef is actually is sometimes quite different to what an ecologist thinks of back reef might be. And so by having like really clear terminology and descriptors about what a back reef is, like hopefully users of the Allen Coral Atlas can then also get clarity in interpreting and understanding the maps. I wanted to say something else that I can't remember what it was.
No worries. So this really means that people from different sectors, different industries, when they're looking at these classifications from your research from Reef Cover, they'll all have the same understanding of it, and then they can converge and collaborate with the same goal and same kind of basic information in mind.
Yeah, I think for collaboration, it's really important to speak a language that everybody's understanding and have a lot of clarity like around those languages. And so just by putting some guidance out there for mappers, creating reef maps, and yeah, like maybe we'll add more things to those reef cover classes in time, and not all maps we'll want to apply all of those classes. So yeah, you mentioned that the Island Coral Atlas only used 12 of the 17 classes, and that's because the Island Coral Atlas only maps relatively shallow to about 10 meters, and some of those classes describe much deeper reef habitats, but at least having some kind of guidance for people mapping would definitely, yeah, like help.
Wonderful. Well, thank you so much, Dr. Kennedy, for coming on. And I am so excited. We're all so excited to see what you're going to do next in your role as coral reef ecologist. But thank you so much for coming on and talking about your research, Reef Cover.
You're so welcome. Lovely to chat to you.